So this is our first video regarding the database in system design, and our today's topic is designing the database. So there are a few steps regarding how to design a database actually, and I'll explain them one by one with some examples. So let's see our first step. So our first step is understanding the business. And this is the most sensitive and crucial part for designing a database. So to understand a business means to know the stuff that needs to be stored in our database. Okay, if you understand the business first, then only you'll get to know what actually needs to be stored in our database. For example, in case of social media application, we need to store things like users profile info, messages and notifications. And yeah, this is the most sensitive part in designing the database. Okay, now I would like to introduce a small term called entity here. Entity is nothing but a real world object or concept that the system needs to store information about. So let's take an example for entities for social media application. Okay, so some of the examples include user, okay, and similarly posts, maybe comments. So this was our first step regarding the database design. Now let's jump into the next step. So our next most step is defining each entity. So this means what info about each entity needs to be stored. Okay, so as we have declared our entities right here in this step, we need to make sure that what infos does this each entity holds. Okay, for example, in case of user, the information could be user ID, name, age, maybe email. These are all the infos that is stored in a user entity. Now let's go through quick SQL example for defining entity. Okay, and as an example, I have taken user and post. For defining users, I have taken user ID, name, email, password, and in case of post, it has post ID, title, and content. Okay, so these all things should be defined according to the business requirements. So before moving into the further step, I want to introduce a primary key here. Okay, so primary key is nothing but a column whose value uniquely identifies each row in a table. Okay, for an example, let's take a user. Okay, user. So how is user defined? So user can have ID, user can have name, and user can have age similarly, and other things, right? But if we talk about primary key, the primary key for user is ID, because ID in this table uniquely identifies each user, right? No matter how many users are there. So that is the main job of primary key. And to declare any particular column as a primary key, we can simply write primary key while writing query in a database. Okay, so because we are talking about keys in database, let's also look up about foreign keys. All right, so to know about foreign keys, I will create an example. Let's say user. On the other hand, let's say we have nothing but a order, right? So how the user is defined? Simply by name, age, ID, and other things, something like this. Yeah. And how can an order be defined? So order can be defined as order ID, right? And to know about who has placed this order, we can also simply put user ID. And this particular user ID is a foreign key right here, okay, which is simply doing nothing but pointing to a particular user in the user table. Okay, so this also creates a relationship which we are gonna study further. So at the end, a foreign key is nothing but a column that references primary key of another table, as we did here, creating a relationship between two tables. Okay, so that was about foreign keys. So let's have a SQL lookup for the foreign key. Okay, for example, we have a review table which holds a review of a particular product. Okay, and we have a product ID here as a foreign key, and obviously review ID as a primary key of this review table. And to make this product ID a foreign key, we have to define a constraint here. Okay, we have to reference it using foreign key. This product ID reference the product ID of the product table. Okay, so we could have a product table which could have a product ID, right? Product ID, name, price, right? Something like this. And this thing here, this product ID as a foreign key reference the product table. Okay, so this was an SQL representation of a foreign key. So as we have seen about foreign key and primary key, we can't forget about constraint. Okay, so the thing we have just saw earlier, that is foreign key and primary key, those are also the constraint. Okay, so constraint are nothing but a rule enforced by DB to ensure the correctness and integrity of a stored data. So what is this foreign key constraint doing here? It is simply associating the product ID with its product, right? With its particular product. So that is also one kind of rule enforced by a constraint. There are other example of constraint as well, which includes not null, means any column can't be null. Okay, the other could be unique, means column should be unique. So a not null representation in a real life could be a password, right? So it makes sure that all the password fields are not empty, because obviously we can't leave password field as empty. And for an example of uniqueness, we can have email, right? So this makes ensure that every email in the database is unique, right? This prevents duplicate emails. So that was very simple. Okay, so there are other constraints as well, so you can explore by yourself. Also, particularly talking about association of entities, there are foreign key constraint as well, and then primary key. These are also the constant. Okay, don't forget about it. And our next step is one of the most important step regarding the concept of the database, that is relationships. So a relationship is nothing but a connection between two entities that describes how they are associated. Okay, let's take an example. In case of our example, I would take teacher, okay, teacher entity, and in the same way, I would take another entity as a student. Okay, so suppose you are building an application for school management system. Okay, just for an example, and what could be the relationship between teacher and student in your application? So the relationship between teacher and student could be something like a teacher assigns homework to a student and student submits the homework to a teacher, right? So this could be one kind of relationship between teacher and student, and this goes same for all other kind of entities. So in this case, relationship is two-way relationship. Okay, because the teacher was assigning the homework to a student and a student in turn was submitting homework to a teacher. But in case of user, let's take an example of user. Okay, but in case of user in a social media application, and in the same way in case of post, so what could be the relationship between user and post? A user creates a post, right? And there's nothing much more than that. This relationship was one way. So to deep dive more into the way of relationships like this, let's go through a type of relationship. So our first type is one-to-one relationship. Okay, and for an example, if we have entity person and if we have entity password, the relationship between these entities is one-on-one relationship, okay, or one-to-one, and this is denoted by 1:1 in this form. One person has one password and one password belong to a one person. So that's why relationship between person and password is one-on-one. So for defining one-on-one relationship using SQL, I have taken person and password. Okay, so first of all, create the table person, which has person ID as a primary key. And in case of password, we have password ID, password num, person ID, and foreign key. Okay. Now, as you can see, person ID here is also unique. Why? Because each person has their only one password, right? So each person can belong to only one password. So that's why in password table as well, the person ID is always unique. And unique constraint enforces one-on-one relationships. So password ID is also unique and person ID is also unique. So that's why it enforces one-on-one relationship. So a second type of relationship in our list is one-to-many relationship. And for an example, I have taken user and orders. Okay, you can simply think that one user creates many orders. For example, if I take any user as an example, user have placed an order for the product shoes, and similarly for the t-shirt, maybe some groceries. Okay, one person can have many orders, many specific order particularly for this person. Okay, let's take an user A. If user A have placed order for shoes, does that same order placed by user A belongs to any other user? For example, user B? No, right? This would be fault in a system. So that's why we place user and shoes in one-to-many relationship. Now let's go through an SQL example for this one-to-many relationship. Let me simply paste this right here. So first of all, we create table user, okay, and secondly we create table for orders, including order ID, which is of course a primary key, okay, and second one is order date, third one is user ID, which is the crucial part here. Okay, now remember we have not used unique key, unique thing here, right? Before, if I'm not wrong, we have used unique here, okay, because this was one-on-one relationship. A person should be unique in case of password, but in here we don't use unique because one user can have many orders, right? So it may not be uniquely defined. And the last item in our list is many-to-many relationship. For an example, I've taken student and courses for the many-to-many relationship. Now let's quickly look this through an example. Draw some students vertically here. Let's say 3 students, and I will represent course by using a circle, and this is third one. Okay, let's make 4 courses actually, just to create some sort of randomness. Let's also notate them for clearance: student and then courses, right? Yep, that does our work. Now let's name all of them. For example, student A, student B, similarly student C, and this is a course for math, for psychology, for computer science, and in the same way mechanical engineering. Now let's see which students have taken which course. Okay, for example, student A have taken math and psychology at the same time. For student B, let's say B have taken course for math and computer science, and at the end student C have taken course for psychology and now let's say mechanical engineering and then computer science. Okay, from the student perspective, a single student can enroll in multiple courses. Okay, for an instance, student A is taking both math and psychology. Yeah, so student A is taking both math and psychology, and student C is enrolled in psychology, computer science, and mechanical engineering, right? Psychology, computer science, and mechanical engineering. Also, from the course perspective, a single course can have multiple students enrolled, right? For an instance, a math has been taken by both student A and student B, right? So because entities on both sides can link up to multiple items on the opposite side, neither side is limited to just one connection, right? Making it a true many-to-many relationship. So up to now we have seen things like entity and many types of relationship, okay? But the question is, how do we exactly know which entity have what kind of relationship with each other if we have to see using a top-down approach, okay, at once, so that it clicks on our mind seeing the first look, yeah? So that problem is solved by the entity relationship diagram, that is ER diagram, right? So let's quickly see the step 4 for designing the database. ER diagram, which is simply entity relationship diagram. The name says it all, yeah? So a visual representation of entities and relationship between them before building the database. Now let's quickly see what are the components of ER diagram. Okay, now let's have a quick look up on the things that you have to keep in your mind to visualize any kind of ER diagram for any kind of application. Okay, so the first thing is entity. Okay, so entity is represented by a rectangular box, and in case of weak entity, okay, so weak entity is a new terminology in our video here. So let me quickly define weak entity. Weak entity is nothing but entity which doesn't have a primary key, okay, or which needs to be associated with any other strong entity or any other entity which has a primary key, with no any primary key, okay, which doesn't have a primary key, right? Now a relationship. So relationship is what we just studied earlier right here, and it is represented by a diamond shape, okay, like a decision box. So the another new thing you can see here is weak relationship. Okay, so weak relationship is nothing but a relationship that connects weak entity. Okay, that connects weak entity, and we represent relationship like this with a strong entity. Okay, and because this is a weak relationship connection, so we make it a double layered. Okay, something like this. So weak relationship is something that connects weak entity with a strong entity or any kind of entity that has id as a primary key. Okay, so talking about attribute is represented by an oval shape. In case of user, we have id, name, age, etc. So attribute is nothing but the properties that define any kind of entity. Okay, so multi-value attribute is also easier to understand. It is simply a property that can hold more than one value for a single entity. Okay, an example includes phone numbers. Okay, because a user can have more than one phone numbers, and hobbies, right? Single user can pursue more than one hobbies. College degrees, okay, college degrees, okay, because any user can take more than one college degree, so that's why it is placed in multi-valued attribute. So these are overall things that you have to keep in your mind before visualizing any kind of ER diagram for any kind of application. Okay, now let's break down the ER diagram for a university management system. All right, so first of all, let's go through each entity. We have faculty, student, courses, department, exams, and then subjects, okay, which is represented by a rectangular box. And secondly, we have attributes. Okay, so the attribute of faculty are id, okay, and name, contact, position, password, and so on. And similarly for the student, the attributes are student name, username, and semester, and the student id and roll number, which are primary key. Okay, So anywhere in the attribute, if you see an underline, so that represents a primary key. Okay, so this student entity have two primary key. Okay, obviously, and it is so obvious. Okay, because student ID and roll number of any university are unique. If we talk about courses, we have course name, course code, and then course ID, which is a primary key. Similarly for the department, department ID and department name, and so on for the others as well. Now let's talk about relationship. Okay, so for a faculty and student, we have one-to-many relationship. Okay, because one faculty can teach many students. Okay, but one particular student cannot belong to many faculty, yeah, and join the courses at a time, right? So that's why it has one-to-many relationship. For a student and courses, we have many to many relationship. Okay, one student can join many courses and one courses can be joined by many students, right? Similarly for the course and department, so one department can have many courses, but one course can't be managed by many department, right? If you take an example for a computer science course, okay, so computer science course particularly belongs to only one department, that is science department, but it doesn't belongs to any other department like humanities, commerce, right? So that's why course and department have one to many. If we say department to courses, and if we say courses to department, it is many to one, it's the same thing. And similarly for the exams and department, and similarly for faculty and subjects, right? So to summarize everything, database design starts with understanding the business requirements and identifying our entities. Okay, then we define primary keys, foreign keys, and constraint to uniquely identify and maintain the integrity of our data. After that, we define the relationship between our entities and represent them using an ER diagram. Okay, and this gives us a clear blueprint of how our data should be structured and how different parts of our system are connected. Okay,